Welcome everyone after a scrumptious lunch. If there was a danger of sleeping before, I can only imagine the dangers now. But so this is going to be relatively short, and it's just kind of to pump you up, prime you for the hands-on. So the hands-on, let me go a little bit about the logistics for the hands-on. So this hands-on, unlike the previous ones, this is going to be deployed on actual hardware. And it's going to happen in Professor Ambika's lab. And assuming there are around 40 some students in person, you are going to work in groups of 3, roughly. You can be 4 if you are 4 friends, or 2 if you hate everyone else. And you will sit at so he has, I don't know, 16 or 15 or 18, okay, more than enough desks. So each group is going to sit at one of those desks and work together. You will work on your laptops, and actually, in principle, you could work individually for the first part, but I think, let's see how it is when you work in groups of 3, because the deployment, so first there's going to be a part where you kind of do the software part, even if we do it in hardware, I mentioned this yesterday, you need to have some software that runs on that hardware. And I'm going to talk about the kind of software I'm not going to spend time now, but that's going to be on your laptop. Then you are going to actually deploy on your smartphone. And then you are going to deploy on some of these Arduino boards that we have. We only have a couple. So because of that, so there's going to be a little bit of a time competition. So the teams the groups that finish first, they will ask the IIT Jammu students to come to them and, with the boards, and you will deploy on the board. But, that's going to happen in, at least 1 hour, maybe longer, 2 hours. I don't know. It's going to take some time before we get to that point. We don't have that much time, actually. And by the way, there is a non-zero probability, depending on the plans for going out today, that we will not finish today. So, we might finish tomorrow. So you start and you do as much as you can today. So yeah, I guess that's kind of it. We'll see how it goes. So let's get close to going. So this is, we talked about TinyML. This is just a more comprehensive table with everything from the applications you see at the top, data sets. These are basically the benchmarks, the models, the frameworks, some of the graph formats, the compilers, the libraries, the OSs, and the hardware targets. It's kind of interesting that only now we talk about this, but whenever you design hardware, in order to determine how good your hardware is, you use some kind of benchmarks. There are some benchmark. There is a benchmarking effort in the community to be able to compare, somewhat apples to apples, different accelerators. And basically and this is not for TinyML, but, this is in general for machine learning, there is this benchmark called MLPerf, ML performance. And basically, again, this already shows you a little bit the limitations. So again, there are no benchmarks for large language models. I think not yet. Maybe there are in this MLPerf, but these are more traditional. And again, there is the split between training and inference. in these benchmarks. And, this is an example of the output of MLPerf inference on different types of models, basically MobileNet, ResNet, all kinds of, and again, I'm not going to spend too much time. Again, that was MLPerf. There is another set of benchmarks for embedded systems. So basically now there is this effort to create a TinyML-Perf for TinyML. And right now, these are some of the categories of benchmarks: audio, visual, basically image, physiological, and industry. And we already kind of mentioned about this this morning. And the kind of the use cases, wake words. So these are the Siri, Alexa, context recognition, control words, keyword detection. And then there is the concept of visual wake words. So again, if a glass breaks, that's a wake word for an alarm. Object detection, gesture recognition. This is kind of important. If I do signs like this, maybe one of these TinyML things can interpret what I'm trying to say and help. Text recognition, we already saw segmentation, anomaly detection, forecasting, we already talked about maintenance and the different types of models. And you see that the models here are, again, quite traditional. So deep neural networks, convolutional, recurrent, this LSTM, which is another recurrent. But there are also these non-deep. I already mentioned this, decision trees, all kinds of other, Bayesian, and the data sets are over here. So in terms of memory footprint, so again, depending on what platform you are trying to deploy to, there is a very wide variety. If it's a Raspberry Pi, it has relatively, large memory. It's really a computer, a small computer, gigabytes. But then, some of the embedded, ones have on the order of kilobytes. And in terms of power, the differences are also quite significant. This is a relatively, small ARM, and this is the Cynthian that I mentioned to you for the keyword spotting. This is the one where my former PhD student worked for. And you see, this is 100 microwatts versus tens of milliwatts. So it's quite significant savings. This is what would run basically on your phone, something like this. So the one actually what you are going to do in the hands-on is going to be keyword spotting. And, it's going to pretty much work, I think, along these lines. It's not, I had some discussions with a student, it's not basically what a large language model does, or it's based on kind of signal processing principles. And, it basically does an FFT, and, you get a spectrogram, and then you analyze the spectrogram. And you do that with a convolutional neural network. There are also these visual wake words, which is basically, is this room, empty, or does it have an occupant? For example, you can use that to turn on the air conditioning or the heating or lights or, whatever. And by the way, I should also mention, so this is a little bit of a conflict of interest, I guess, but these benchmarks are owned by companies. And I think there is a little bit of a conflict of interest when you own a benchmark. There is a temptation to make the benchmark look better on your platform. So I'm not sure how they are dealing with that. But this one is owned by Google. This one is owned by some a company that I haven't heard of, to be honest. But this is for anomaly detection. And then this one is for image classification, which is the typical, CFAR 10. This is, and the model is a ResNet 8. Now, there were some questions about how do you make a model more compact. And these are basically some of the techniques of quantization. Sparsity means you get rid of some of the weights, you make them zero. Pruning is another way to do the same thing, and and retraining is important in order to get back your accuracy lost. In terms of TinyML platforms, anything from CPUs, GPUs, FPGAs, ASICs, and with the different trade-offs between flexibility, CPU being the most flexible and ASICs being the more efficient. These are, this is a list of platforms that are being used for for TinyML. We have several of these boards actually, with us, but for now at least, we are only going to use one of these. I think that one, this Arduino. Actually, the first one on the list, the Arduino Nano 33 BLE Sense, which is this one in that corner. I think in my box I have this one and this one also. This is the box that I'm talking about, and this is the Arduino board by itself, and we're really just going to use that one. But you could, in principle, use, there is a camera here, so you could do something in real time. I'm not going to talk about this. There are several ways. So this is basically how to use this TinyML on Arduino. But something that we are going to do, and again, it's a little bit like with the other assignments, I'm trying to make it a little bit easier. So, instead of doing CUDA programming, we use these PyTorch, libraries, NumPy and all that. A little bit like that here. We could do a TinyML implementation that's more, code heavy, so to speak. But again, in the interest of making it more straightforward, we are going to use this kind of no-code development method in which basically you use a GUI, with the development platform that kind of makes it very easy. And with this, we are done. So have fun with the lab. If there are any questions before, actually, if not, show them up to the lab. And by the way, for the online people, I think the plan is that the IIT Jammu students will have a camera in the lab, and they will show, the people online actually can do the deployment on their phones. But for the deployment on the Arduino, they are going to show on camera. Okay.
One other laptop so that you can focus there. Well, let me continue.
So I think they are already there. I think they are already there.
Okay.
Yeah.
So. They will go there, right?
Yeah.
So, okay, let's move to the lab. And do we have some here too? Around 20, right? These are the 4 chairs that we can take.
Yeah.
4 that one. Otherwise,
Well, and some people can stand. Take
no
turns.
problem. They can see it. Yes, sir.
Eh?
हाँ आजकल नहीं होगा इधर का खेल करता हूँ इसको बंद कर दिया वहाँ से लॉगिन कर लेंगे लॉगिन दे तो ये कुर्सी के सब लोग लेके चलो बच्चों चाहिए चार लोग लेके आओ
कैसे करते हैं ये देखिए
Link people have you done? Keep the assignment.